A grounded metallic ball of radius r is placed on center of a uniformly charged thin insulating disk of radius capital R, where capital R is very large as compared to small r. If total charge on a disk is capital Q, find the force of interaction, electrostatic interaction between the ball and the disk. And this is the answer. This is a question from Pathfinder, and let's see how to do this. Suppose this disk is made up of many thin rings. Consider one such ring of radius small r and thickness dr, and the potential caused by this small thickness ring at the center is given by EV equal to kq by r, where q means charge on this disk of very small thickness. So it's sigma into the area of this ring, and area is its length 2 pi r into its thickness dr. So the formula is kq by r. So this is the potential caused at the center of disk due to this ring of radius r and thickness dr. And since this disk is made up of many such rings, we'll have to integrate this formula to get the total potential EV. So this you have to integrate from 0 to capital R. On solving becomes k sigma 2 pi capital R. Electric field near the center of disk, we all know, is given by this formula sigma by 2 epsilon naught. So these are the two formulae we're requiring in this question. So we have a disk, and this small sphere is kept near its center of the disk, and it is connected to ground. Now suppose the sphere acquires a charge Q, and this charge will be from Earth. And since this disk is a non-conducting disk, so whatever charge is given to it, this will remain on the disk itself. It will not flow since it is a non-conductor. Okay, so first we'll be finding how much this charge Q will be on the sphere, metallic sphere. So the property of this being earthed is the potential of this sphere will be 0 everywhere, and the easiest point to calculate the potential is center. So we are finding the potential at center. Potential at center due to this Q charge, assumed Q charge, is kq by r, and the potential near the center of disk which we have just found is k sigma 2 pi r. We have just found here r. This is the result. Okay, so this is the total potential at the center of sphere. This is potential due to disk, and this is potential due to the charge acquired on this sphere because it is connected to Earth. And this total potential at the center should be 0 because it is connected to Earth. So this will give the charge acquired by this sphere, and now a force will act on this Q charge because it is placed in the electric field of this disk. So a force will act, and that force will be simply Q into electric field, Q into E. So Q we have found, E we know, sigma by 2 epsilon naught, and simply we have to put the value of sigma now. So sigma is charge density on this disk. So it is given in the question that the radius of disk is capital R, while the charge given to the disk is capital Q. So sigma will become total charge over total area. Fairly a question that seems to be simple, but it's very hard to think at the first attempt, because questions of this form, they need thinking before they can be solved. Okay, and that's the beauty of questions from Olympiad. Before you can solve, you need to think a lot how to solve, how to tackle that question. Okay.